Hi, welcome to this session of understanding how the triac is used in combination with an opto isolator, and particularly a LED and diac combination opto isolator. They are termed as MOC 3020, 3021 and several other numbers, and they are non-ZVS type opto. Non-ZVS type opto means it can switch on not at the 0 but anywhere the triggering is made. We will see that with this kind of arrangements. We have a supply here, and then we have a lamp here, we have a triac here. All of them are in series. The gate is connected in this fashion from the diac combination of the opto isolator, and we know that the triac can conduct only when the gate is triggered. Triggered means the current has to flow in the gate and M1 circuit. This is M1 and this is M2, or we call it sometimes A2 and A1 of the triac. That means, now supposing for example we will just see as to how it works, that when this side becomes a positive, supply goes this way. In the positive half cycle it goes this way, it cannot go this way, it goes this and then enters, and then it conducts only if the light is falling on this. Let's assume that the light is falling on this, so it goes this way and then enters the gate, comes out at the M1 terminal, passes through this lamp and then reaches here. And that is how the path in the gate and M1 is complete. Once the path between gate and M1 is complete, the current starts flowing, but for that positive half cycle straight this way. For that positive half cycle. And for the negative half cycle, similar. So now this is negative, it goes this way, enters the M1, comes out of the gate, goes this way and then conducts. If it is light is falling on this and goes this way, it cannot go this way, it goes back to the source, and only then this conducts directly like this. So in positive half cycle it conducts this way, and the negative half cycle it conducts this way. This is how the load is switched on in both the cycles, in both the half cycles, because the triggering takes place in each and every half cycle. And from an opto how it works we will see. Now when we switch on this, we will take the CRO down and we'll see. And when we switch on this, you can see the arrow mark, and this is in the 0 now. And once we make it 1, we find the lamp starts glowing. The lamp starts glowing, of course in a little erratic way because of the simulation problems, and we can see the arrow in direction in which the current is flowing and the lamp is glowing because we have given a logic 1. Logic 1 means this current flows through the LED, and since it is continuously flowing through the LED, if you could see the waveform, we get the output full sine wave. And this is the voltage which I have given. If you see the ground of this particular voltage, this is the level, and I am giving almost 5 volts. This is 0, so 1, 2, 3, 4, 5. If I give 5 volts, then the LED glows inside, and that is how it works. And if I make it 0, the lamp stops. Even if the supply is available, the gate current can still flow, but the main current you find it is not flowing. Only the gate current is flowing, but the main current is not able to flow. It's just because the gate current is also not flowing, though it is showing like this. The gate current is the main current cannot flow because the gate current is not flowing. In simulation you might be seeing something like this, but actually the gate current is not flowing because this circuit, this path is open. Once this path is open, the gate circuit cannot be completed. In the process, the lamp doesn't glow. And only when I make it 1, you see the lamp starts glowing and the supply voltage is full. If I make it 0, the output is 0. If I make it 1, the output is full. This is what we can see in the CRO. And once we go over to supposing a delayed firing angle, we give a delayed firing angle. Let's see in this position. We bring it to this position where I am giving a delayed firing angle. In a delayed firing angle situation, what we can see that in this situation, I find this is my waveform and the lamp is still glowing, and this is my waveform. How it works, we will see. The working principle is, now let's analyze this way. Okay, now this is the 5-volt pulse what you find, which is coming from the LED. This opto LED is glowing only for this much of time. The opto LED is only glowing for this much of time, and this much of time it is off. So the mains supply, for example, when the mains supply, let's go over this way again. Now when this becomes a positive, it goes this way, and it cannot pass this way to complete the circuit, goes this way, it conducts only after 5 milliseconds. That means from here to here you have 5 milliseconds, and from here to here the LED is off. You can see the LED is off because the LED is off. It comes and stays here, waits till the LED is on. The LED is on only after 5 milliseconds. Because the LED is on after 5 milliseconds, the triggering takes place after 5 milliseconds. Because the triggering takes place for this positive half cycle after 5 milliseconds, and that is how the current flows this way, and you get the positive half cycle like this. For the negative half cycle also, the similar way, the pulse comes after 5 milliseconds. So when the negative half cycle, this goes this way, and waits here, because the light is still not falling. The light is falling after 5 milliseconds. After that, this goes this way, and the path is complete. Once the triggering path is complete, the main path flows, and that's how the lamp glows, and we get the waveform of this nature. As you can see, this is the type of waveform that we see. And so the basic purpose of this particular video is to understand that how the MOC 3020 series or MOC 3021 series opto isolators are used either directly from the logic gates, where of course you will not have any control over the gate current. It's just because anytime the supply comes, it switches on. But if you switch over from this particular IC to another IC which is called MOC 3060 3063, they are 0 voltage type, and you will get always 0 voltage switching. So that is the biggest advantage of using opto isolator. From the triggering takes place from the same source. It's not that we need any other source compared to pulse transformer concept, where this is a better solution because this is an optical isolation as compared to the pulse transformer isolation. You can see this DC side is completely isolated, where this is completely isolated. This is AC side. This AC side is completely isolated, and that is how this gives the best advantage as far as the using opto isolator for such situation.